Hi everyone, let's discuss a Leetcode problem today. And today's problem is problem 973, K closest points to origin. So the problem description says, given an array of points where each point is actually a pair of values, x and y, and that value represents a point on the xy plane, and an integer k, returns the k closest point to the origin. So say if we have these points, okay? Say we have these points, all these points. Someone says return the value of k is 3. That means return the nearest 3 points. So obviously these are going to be this one, and probably this one, right? So we have to return these 3 from the origin. This is the origin. So these ones are the smallest ones, smallest distance ones. So distance between 2 points xy plane is the Euclidean distance. Obviously, we know, all of us know these equation, right? If this is like if there are 2 value points x and x1 and y1, and then the second point is x2, y2, then this is the distance, right, between these two. And the other thing is, these may return the answers in any order. The answer is guaranteed to be unique. Okay, so the problem description hopefully is clear to you. Let's talk about the solution. So we know that distance, say if there is a point, let's say x1, xi, yi, if there is a point, what is the distance from the origin? So it will be xi minus 0 whole square plus yi minus 0 whole square, and then we have to put a root over, right? Okay, so we can actually discard this root over thing, because if a distance is like 3, other distance is 4, then if I remove the root over, this is going to be 9, this is going to be 16. Still the thing exists, like which one is smaller, which one is larger. Since we are just looking for the smallest distance from the origin, we can just keep we don't need to do a root over or something. Anyways, for the kth closest ones, how can we do this? So obviously what we can do is we can calculate the distance of each of the points, and then we can sort them. Can we do that? Yeah, obviously we can do that. Okay, so what is going to be the time complexity? So we sort them and then take the first k or last k, right? Depending on whether we are doing descending sorting or ascendant sorting. So sorting is going to be, if they're like n points, it's going to be n log n. Okay, and then we also have to keep an array of space n. Instead, can we do better? So probably k closest, this term may build some ring. Okay, so what about we, instead of getting an array and other things, what about we put everything in a priority queue of size k? So we want to keep the smallest distance ones, right? So if I want to keep the smallest distance ones, I have to make it a max heap. That means if the root of the heap is a is going to be greater than everything in the heap, b. That means the smaller values are here, the smaller values are here, right? So if I keep a max heap based on the distance from the origin, in that case, the smallest distance are going to be here, right? So we can keep track of the points that has the smaller distance. So let's build a max heap of size k and keep on adding the points based on the distance from the origin. Okay, so let's do this and try to code this. Okay, so I have already solved the problem. So you see, I have a priority queue of initial size k, and I have to turn this priority queue into a max heap. By default, the priority queue in Java is min heap. So this is a priority queue of arrays. And these arrays are like each of these arrays are the points. So x coordinate and the y coordinate. And by default, if I am like putting two coordinates, like 2 points, A and B, it's going to be in the min heap. The relation is going to be the distance from A. So I'm defining the distance. And since I want to change it to a max heap, what I'm going to do is I am reversing the comparison. So this is the distance. You see B0 into B0. This is the x coordinate, and B1 and B1. So this one from the high school algebra, geometry or algebra, you know that this is the distance between the origin and point B. And this is the distance between origin and point A. So from this distance, we subtract this distance, right? And that is a criteria to put into the queue. And that one turns the min queue into a min heap into a max heap. Then we declare a 2D integer array with size k. This is going to have, the result is going to be stored here. Next, we have this input array. We read from this input array, add to the queue, priority queue. And if at some point the size of the queue tries to become greater than k, we just get rid of one item, that is the top item, that is the largest item of the queue. That way we always are keeping the size of the queue to k. Next, until the queue is not empty, that means the k elements are now in the queue. Until the queue is not empty, I just take one element out of queue and adding it to the result. Okay, and so I'm taking one element out, adding it to the result, and finally returning the result array. Okay, so let's see what is the time complexity of this algorithm. If this is like, say, of size n, if there are like n points, in that case, you see that I have run this for loop, say, n times, and added to the queue. You know that the adding to the queue is order of log of size of queue. So the size of the queue we maintain it as k. So it will be order of log k. So in n elements, n into order of log k. That is how many times I'm doing this. And this for loop I'm running like k times. So the time complexity is going to be order of n log k, where the k is the value from here. Okay. And the space complexity is going to be order of k, because this is the priority queue extra space that I'm using, and the priority queue size is maximum of k. Okay, so the time complexity is going to be order of n log k. The space complexity is going to be order of log k. Sorry, order of k. That is the size of the priority queue. So hopefully you enjoyed the discussion and understood the problem. If you haven't, I would suggest like rewind the video, watch it carefully, and hopefully it will be more clear to you, and try to code it yourself. So thanks everyone for watching. Till next time, goodbye.